Hey class, today we're going to talk about relations and functions. So we're going to start off with a few definitions because we got to know what these things are before we can actually put them into practice. So first off, a relation is a mapping or pairing of inputs and outputs. All right, so you have, in an equation, you have inputs and you have your outputs. A relation is the actual relationship between those inputs and outputs. Okay? Within a relationship, we have the domain, which is always our input values, and that's always going to be our x values. Okay? So if we're looking at a relation, an actual mapping of inputs and outputs, our x values are always going to be our domain. So these are going to be our domain. Over here we have a list of coordinates. Our domain here would be 4, 3, 2, 1, because our x values are our domain. Okay? So domain is our input values, our x values. In an xy table, that's going to be on the left. In coordinates, again, that's going to be on the left. Those are going to be our x values, will be our domain. A non-example over here, our domain is not our y values. So if I circle these, that's not going to be right. Okay, these are our y values. Those are not our domain. All right, those are actually going to be our next one down. Those are our range, our output values. Okay, and our output is always our y values. So looking over at our example, well, if it's not going to be our x values, it's got to be our y values. All right, and that's going to be this one, this one, this one, and this one. Our y values, that's 1, 1, 2, 3, 4. Okay. Our y values are our range, so that will not be our x values. Okay? Alright, so if we have inputs and outputs, and every input has one output, then we have what's called a function. Okay? A function is when every input has exactly one output. Okay? It cannot have more than one output. If it has more than one output, it is not a function. We'll get a little bit more into that in about a minute. Okay. After functions, within functions, we have independent variables and dependent variables. These go with these up here. Our independent variables are always going to be our inputs, which are x. Okay, so independent variable is our input. Our input is also our domain. Our dependent variable is going to be our output, which is always y. Dependent variable, output, which is always y. Alright, so next up we got to figure out, is it a function or is it not a function? Alright, so let's figure this out. Up here I have this star. This is very important. Each input in a function can only have one output. This is what we just talked about, okay? So we're talking about functions. Each input can only have one output. That means each x value can only have one y value. Okay? So looking at our first mapping here, this is a data chart, and our x values are over here, and our y values are over here. So all we have to do is look at our inputs and make sure that they each only have one output. So I'm going to go through and ask myself, I see this input, what is its output? So I'm looking at 14. The output of 14 is 1. It has one output. Looking at -2, the output of -2 is 1. It has one output. Looking at 0, the output of 0 is 3. That's one output. Okay, so is it a function? Yes, it is, because each input has exactly one output. Now moving over to this one, I'm going to do exactly the same thing. Looking at 16. 16 has one output. That's 5. Okay. If I look at -22, its output is, it's either 6, it's 6 and 17. So -22 has two outputs here, which makes it not a function. So that is not a function, because -22 has two different outputs. Alright, this is data given to you in a chart or a table form. Alright, as we're looking at this, we're still going to do exactly the same thing we did before. So looking through these, we're going to say to ourselves, 0, its output, y, is 6. That's one output. 1, its output y is 5. 2, its output y is 4. And 3, its output y is 3. So each of these has one output, so yes, that one is a function. Moving over to the next one, we're going to look at this. 0, its output again is 6. Move down to 1, its output is 5. Move down, we have another 1. Its output is 4. So that means the output of 1 is 5 and 4. That means the input of 1 has two different outputs, which makes this not a function. Okay? So because 1 has two different outputs, 5 and 4, this is not a function. Because each of these have one output, it is a function. Alright, the last thing we're going to learn about as far as determining whether it's a function or not is called our vertical line test. When we use the vertical line test, we are using a vertical line. Vertical line is this way. Alright? And it says if a vertical line touches a graph more than once, then it is not a function. So I'm going to use a different color. And the idea behind this is if I can draw a vertical line anywhere on this graph and it touches the circle more than once, then it is not a function. So I'm going to draw a vertical line, and again, this could be anywhere. I'm just drawing it right here. So that touches the graph here, and it touches the graph down here. That means it touches our graph twice. Therefore, according to our vertical line test, that is not a function. Okay? Now, you might be asking yourself, well, why is that not a function? Well, the reason is, for this value of x right here, we have two y values. So that'd just be like over here, for the value of x of 1, we have two different y values. Same idea here, for the value of x, that'd be right around -3.5. We have a y value of 6 and a y value of -6. Okay? If we have two different y values or outputs for the same x value or input, then it cannot be a function. The next thing we're going to talk about is actually graphing a function. So what is it going to look like for us to actually put a function onto a graph? What are we going to get? What are we going to find? Well, there's a couple steps for this. Our first step is to look at our equation and then select x values for our table. Okay, so this method always involves creating a table, and we're going to select x values for our table. All right? These x values are random. We can pick any x values we want. Whenever you pick these x values, you're going to do step 2 and substitute them into your equation to find y. As long as you plug a value in for x, the relationship that's given to you here will give you a proper y value. Okay? So we're going to choose x values, plug them in to find y. Alright, let's begin. When I select x values for my table, alright, I want to select positive and negative numbers, and I want to have at least 3 numbers that I choose. Okay? That's going to give me a good representation of the graph when I draw it. Okay? At least 1 negative, at least 1 positive, and at least 3 numbers total. Okay? So, that being said, let's start off with -1. Then we'll do 0, and then we'll do 1. Okay? And I'm going to go ahead and plug in this first one and see what I get. So I get y equals 3/2 times -1 minus 4. And I'm going to solve this out and see what I get. So I get y equals -3/2. 3/2 times -1 is -3/2 minus 4. Alright, now I've got -3/2 minus 4. I've got to subtract fractions here. So I need to find a common denominator, which is going to be 2. And if I make the denominator 2, I've got to make the numerator 8. -3 minus 8 is going to give me -11/2. And that's what y would equal. And we'd have to plug that in. -11/2. Now when we go to plot this point, we're going to have to graph a coordinate at -1 and -11/2, which would be 5.5. So that'd be right down here. Okay. Now how many of you like graphing fractions? I don't. To make this easier, let's erase what we just did. And I'm going to get rid of my inputs here. Except for 0. To make this easier, let's choose numbers for our inputs that are going to cancel out our denominator and give us whole numbers instead of fractions. Alright, so let's give this a try. The easiest way to get rid of your denominator is to always choose input values that are multiples of your denominator. Okay, so multiples of 2 are what we're looking for. So that could be 2, that could be 4, 6, 8, 10, 12, so on and so forth. Alright? We don't want to pick huge numbers, we want to keep it small and simple. We still want a negative one. So I'm going to start, instead of with negative 1, I'm going to start with negative 2. And then my biggest value, I'm going to use 2. Alright, now let's plug these in and see what happens. Y equals 3 halves times negative 2 minus 4. Okay, 3 times negative 2 is negative 6. So I get y equals negative 6 over 2 minus 4. Negative 6 divided by 2 is negative 3. So I get y equals negative 3 minus 4, which gives me y equals negative 7. So my first coordinate is negative 2, negative 7, which is much easier to graph than 11 halves. Alright, now I'm going to plug in my next number. My next one is 0. Okay, so I'm going to erase this so I have room to write. And I'm going to plug in 0. Alright, so I'm plugging in 0 now. I got 0 from right here. I'm plugging it in to see what I get. 0 times anything is 0. So I get y equals negative 4. So my second coordinate is 0, negative 4. Now I'm going to plug in the last one, which is a positive 2. So I get y equals 3 over 2 times 2 minus 4. Again, we're doing 3 halves times 2. You multiply straight across and you're multiplying fractions. So y equals 6 over 2 minus 4. That's going to give me y equals 3 minus 4, which will give me y equals negative 1. So my last coordinate is 2, negative 1. Alright, step 3 is plot the points. So I'm going to go over here and I'm going to look for my first one. Negative 2, negative 7 is going to be right down here. 0, negative 4 is going to be right here. And 2, negative 1, 2, negative 1 is going to be right here. Then all you got to do is draw a line through them. And we're done. That is how you graph a function. Alright, the last thing we're going to learn how to do is learn how to evaluate a function. So evaluating a function is pretty similar to what we just did. You're going to plug in numbers and evaluate to get your answer. We're going to simplify to get our answer. This one says f of x for f of x equals 3x squared plus x minus 2 for f of negative 2. This right here is what always tells us what we're plugging in. F of whatever, that number, is what we're plugging in for our variable. Okay? So as you can see, we replaced x with negative 2. That's what we're going to do in our equation, is replace x with negative 2. Alright, so the first step says substitute using parentheses. So every time I substitute this in, I want to keep it in parentheses. So I get 3 times negative 2 squared, don't forget that squared, plus parentheses negative 2 minus 2. Now I'm going to simplify this I'm going to evaluate using PEMDAS. And we all know PEMDAS stands for parentheses, exponents, multiply, divide, add, subtract. So I'm going to look for parentheses. I see I have parentheses here and here, but there's nothing to do inside of those parentheses. So I'm going to cross that out and I'm going to move on to my next one. Exponents. I have an exponent right here. That means I need to do this exponent before I do anything else. So negative 2 squared gives me negative 2 times negative 2, which is positive 4. So I'm going to bring that down and bring everything else down. Next, done with the exponents. Multiply or divide from left to right. Okay, I see multiplication right here. 3 times 4, that's 12. I'm going to bring everything else down. So multiplication and division is done. Add and subtract from left to right. So we've got 12 plus negative 2. 12 plus negative 2 is going to give me different signs. That's going to subtract. That's going to give me 10 minus 2. Got one more subtraction to do. 10 minus 8 is going to give me 2. So my answer would be written f of negative 2 equals 2. Alright, now you know how to evaluate a function. You know how to graph a function. You know what a function is. You know what a relationship is. You know what inputs, outputs, domain, and range are. Great job. Have a great class.